Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example of one of the review questions for Test 2. This is from section 6.5, page 429, number 22. And we have the function here, y is equal to the tangent of 1/2 x. And it says graph the function, make sure to label any key points and show at least 2 cycles. And it says use the graph to determine the domain and the range of the function. So with this, it's really good to know what the graph of just y equals tangent of x looks like, and then to kind of extrapolate from there. So tangent of x, we just have kind of a normal graph here. Put little arrows there. And we've got like a pi over 2 here. And I've got a little negative pi over 2 here. And I've got over here 3 pi over 2 over 2. And over here negative 3 pi over 2. So remember, tangent of x, we can also think of that as equaling sine of x over cosine of x, right? Cosine of x. So it's going to actually go through the origin right here, and we're going to have nice vertical asymptotes. Hold on just a moment here. Like this, and I didn't really draw this to scale here, but you'll have another one here, and it kind of goes up like this, down like that, and then it'll do the same thing going through the x value of pi there, and negative pi over here. And it does this just kind of going infinitely in both directions. And we can kind of verify this on our calculators as well. So let's go ahead and do that. So if I just go ahead and make sure that, let me clear this out of here, and I am in radians. So if I just graph the tangent function, so tangent of x, and graph it, and let's get a standard mode. It's going to kind of give me this graph here. All right. So what is it? What happens when I multiply my angle by 1/2? Well, this 1/2 here, that is our omega, right? So in our standard form here, it's going to look like this. Y is equal to what? A times the tangent of omega times x plus b. So if we have it in this form right here, this value here, we can use this in order to find our period of our new function. And our period of our new function is just equal to pi, because pi is the period of our original function here divided by whatever this omega is there. So in our case here, our omega is 1/2. So our period for our new function is just going to be pi divided by 1/2, which is equal to 2 pi. 2 pi. So this means that our period is basically getting doubled. These things are going to be kind of stretched horizontally out doubled here. So instead of this thing, it's still going to start at the origin here, but instead of kind of going up to pi over 2, it's going to be stretched all the way out to pi. So our new graph should kind of look like this. So instead of doing our vertical asymptotes at pi over 2 and negative pi over 2, we should go all the way out to pi, and we should go all the way out to negative pi. So, and we should have an asymptote there, and one here. And it should look something like this, and coming down like this. And I could probably do that one a little bit better, but approaching those asymptotes. And then over here, if we went out further and did another full cycle, we went out to, remember, it's a 2 pi, so we got to go out 2 pi, so that's going to be 3 pi over here. And we have another asymptote there. And so 2 pi is where it's going to be our x-intercept. And we're going to go all the way up here and down like this. And this should be a smooth curve, by the way, in there. Which I didn't really make it a smooth curve, but it should be pretty smooth. And it'll just keep going infinitely in both directions. So what does this mean for our range in our domain? Well, the range is going to still stay the same, right? It's going to be from just negative infinity to positive infinity. Those are our y values. But our domain is gonna change. Our domain, it went from like pi over 2 to 3 pi over 2 to 5 pi over 2. So we could have written our domain before like this. If we're putting in set notation, we could have put it like, just a moment here. For the tangent of x, set notation would have looked like x such that let me see, x is, oops, sorry, not equal to k times pi over 2, and where k is an odd integer, where k is an odd integer, right? And what does this mean? This means that if we put an odd integer in here, so if you put a 1, that would be pi over 2. If you put a 3, that would be 3 pi over 2. If you put a 5, that would be 5 pi over 2. If you put a negative 1, that would be negative pi over 2. That means for any of these angles, x is not in that domain, right? So it excludes all of those x values there, because for all of those angles, the cosine of x is basically equal to 0, which puts a 0 in the denominator of that. So for this one, it's going to be very similar. It's going to look like this. It's going to be squiggly line x such that x is not equal to, now this one is going to be negative pi, pi, 3 pi, 5 pi. So really it's just odd integer multiples of pi. So this one we can just write k times pi, where k is an odd integer. K is an odd integer, and I did leave myself enough room there, is an odd integer. But something like this would be fine. And if you were writing it on a test, as long as I could understand what you were saying and it made sense, you would get credit. If you also wrote it like this, this would also be good. If you wrote the domain like this, like a dot, 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 and then you did like a negative 3 pi, negative pi, pi, 3 pi, comma, with a couple of more dots there, like this, and said, these are not in your domain. I mean, that would be good as well. Just something so whoever's reading this can tell that that these values are not in your domain. All right, and then the key points for this new one, we definitely have 0, 0, right? We definitely have 2 pi 0. So those are going to be key points there. I would also give values halfway between 0 and pi, and then the corresponding y values for that in between 0 and negative pi. So that's going to be pi over 2 and negative pi over 2. Put those inside my function and evaluate. I'll let you do those. And then you can also do halfway between 2 pi and 3 pi and pi and 2 pi, and then evaluate those to get your y values as well, and then mark those points as key points as well. All right, I hope this helps. If you have any questions, let me know, and good luck on the test. Thanks.